Good morning, everybody. It's a beautiful day today, isn't it? Compared to yesterday, that is correct. It almost reminds me of our geothermal projects, even though all days are same, but they're different. All geothermal projects are geothermal projects. They're supposed to be same, but they're always different. There are different challenges, just like every day. So quickly to go over what I'm going to cover today is the US current market, our budget profile, the regulatory roadmap that we are doing it to accelerate the development of geothermal projects, different policies starting from 74, but I'll more concentrate on the recent policies, the impact of those policies, path forward, where really we want to go, and then I'll try to conclude it quickly. Some of you may have heard our president's this quote. He talks about the path forward for sustainable energy, and he says that America cannot resist to transition and cannot wait but must lead. So you question why? Because nowadays, we are not just a national economy. We are in a global economy with a developing rapidly at a faster rate than we can realize. In the United States, as well as the other developing countries, as they are catching up and closing the gaps, we need to create more jobs. We need to create more jobs in terms of clean jobs, green jobs, and also enhance each and every nation's energy security. Energy security, so many times we have related to one of the utility needed for us. Many of you have played the board game called Monopoly, and there are 3 utilities on that board game: the water, then the utility, and the railroad. We have always known about the railroad and the water. Energy is our third. It is necessary, okay? It is going to be required for us to move forward. And then we should be able to protect our health and safety, and therefore, the clean, sustainable energy is important. What have Department of Energy done in last 4 years? In the first administration of President Obama, we have doubled the renewable energy just by wind, solar, and geothermal. So you can see that in the United States, we have made a tremendous progress. Just last year and this year, we have brought in approximately 150 megawatt in the United States. Just 2 days ago, one of the most new plant was announced in Oregon at Neil Hot Spring, which is 28 megawatt in capacity. So it tells you that in so many years, for the first time, the United States has seen a growth in terms of triple digit or the percentage-wise in double digit. How did we do that? Everybody wants to know that question. How can you do that? That is, as you can see that almost in 2007, our budget was zeroed out. Prior to that, we have a healthy budget appropriation of $20 million. Thanks to MIT report on EGS, we were able to revive Geothermal Technologies program. Very hard work done by the MIT panel. They really worked hard to really define the potential of geothermal and say why we need it. So since then, we started getting more money, and you're going to say, is this all you're getting? One thing I have left out is 2009, we received $400 million of portfolio that only 3 of us in our office were able to execute in 1 year. That is the American Recovery Act, and $400 million were given just to geothermal program. So if you put that number here, and I'll show you that later on, how impactful that is. And how are we doing this with this money? We're really creating our geothermal energy affordable on EGS, on hydrothermal, as well as the co-produce and I'll tell you what co-produce means. And we are also breaking down the barriers. You're going to say, how are you going to do that? Breaking down the barriers is very important in the United States. The United States leasing, the permitting, after you own the land, it takes several years. In some cases, each and every project on a public land has to go through the environmental permitting process. We call that NEPA. Last year, we started a process called Regulatory Roadmap. In this process, we identify what the federal regulations a public investment has to go through. What are the federal, state, and local requirements are? And we develop an as-built flow chart so any developer can go there and find out. We did that for 8 Western states. This year, we are embarking on a 9th and 10th state, that is Colorado and Texas. And then, once we have that, this roadmap will allow us to identify the duplications, the inefficiency, and also some barriers that other regulators or the decision maker needs to do that. So that's one way. The second is, as you know, that we have implemented so many different policies. It starts anywhere from 10% credit to 30% treasury cash grant. We also have the production tax credit, investment tax credit, and along with all of those, we had several financial assistance program where we provide the grants, a cost-shared grant, where the project fails or succeeds, you're not obligated to return that money back to the government. So let's look at this quickly. One of the things is 48C. That's simply the Advanced Energy Manufacturing Tax. This came out under Recovery Act, and it was $2.3 billion. In geothermal, finding the advanced manufacturing was very difficult when we got that. We were still able to qualify 2 companies, one for the drill bits and another one for the heat pump, to provide them approximately $9 million for the advanced manufacturing. The second one, loan guarantee program. The loan guarantee program is not new, but under Recovery Act, it was revived again. Our original loan guarantee program started in 74, 75, and you can see that on the top right-hand corner, we have funded initially 4 programs and then went out and funded a lot more. One of the company present here in the audience, Ormat Technology, received the first loan guarantee program from the Department of Energy. That was their first geothermal project in the United States or in the world. And today, they are one of the leaders in deploying vertically integrated geothermal programs. They develop, they build, they construct, and they operate power plant. I don't want to make sound like this is an Ormat commercial, but I want to show you how the United States has made an impact by various different policy. Recently, we also funded 3 more. One of them was Ormat Technology. They have 3 projects. 2 of them are online. US Geothermal, just told you 2 days ago, it came online. And Nevada Geothermal Power, Blue Mountain, that also is online. Cash grant. Why use a cash grant? This morning, we had a lot of problems, a lot of risk, or last 2 days, that the issues is upfront cost and risk. This cash grant allows people to capture or needed capital from the treasury in the beginning of the project so they can leverage that and expand more. As you can see that we have spent over $500 million in cash grants to so many different projects, okay? Along with all those federal incentives, at the state level, we also have what you call the renewable portfolio policies. renewable portfolio standards. Some of them are mandatory, and some of them just are goals. For example, California has a mandatory of 33%, and California are on schedule to meet 2020 goal of 33%. Even though a lot of states, almost 21 of them, don't have it, but these are also important in order to pursue and move the geothermal projects rapidly online as well as the economical. The third part I was telling you that the geothermal program also does is a financial assistance. Almost every field in the United States, and so many of them abroad, we have funded financially. We do it in 3 different manners. One, we fund our national laboratories. Our national laboratories are funded in a non-competitive basis where they either develop new tools, modeling activity, or research where they go to that particular field, study it, and then develop the tools, and that those tools are available. For example, in 1995, we funded a project where at Salton Sea had a lot of problem with silica scale. In the beginning, we didn't realize it. We just wanted to help Salton Sea come online, so we did a lot of research in silica. Ultimately, in 2005, our national lab, Livermore, did a technology transfer of mineral extraction technology to Symbol Material. Later on, we selected Symbol Materials again, gave them a $2.5 million to start a power plant to extract lithium technology. That lithium technology, if and when it's developed, will provide 600,000 to 800,000 vehicles batteries for those vehicles by year 2014 and 15. So that shows you geothermal impact, just investment in research, years later pays off. All these states here on this list were developed with the help of Department of Energy's, those type of research and financial assistance and other investments. So in short, from the policy perspective, what are the key takeaways? I did not mention a lot about the PURPA. On my next slides, I'll have the impact of the PURPA. This is the Public Utility Regulatory Policy Act. This was very much instrumental in getting the initial install capacity in the United States. This is one of the old policy measures, and that's why I didn't mention a lot about it, but I'll show you the overall impact of all those policy instruments. Once again, just like every day starts same, you get up and do things, but turns out different. Same way, for every country and geothermal projects, you don't need one policy tool. You need multiple. You need a different, because they have a different impact and different results. Okay, so this is not where you get a one tool or one solution and it fits all projects. Second one was loan guarantee, cost share drilling. So on the projects I showed you earlier, we've done an industry cost share project. This is where we paid them 30 to 50% of their cost of drilling just for the return of data. Okay, that's a grant, not a loan, no commitment to get that money back again, because it's going to be a public good. The more we know about those projects, more it will be used in future. And also the program research and development announcement. Once again, those are some of the examples I gave you, was like a national lab. The second one is the university grants. We also fund the universities, where the university collaborate either with the industry fields or even some cases the international communities, and develop and advance the research. And then finally, the third part was the demonstration project. And later on, I'll show you some of the accomplishment in our demonstration projects. So current portfolio, Once again, we have the tax credit. As you can see, the cash grant, as well as the PTC, production tax credit, ITCs, as you saw. And then all those things, the current geothermal market was developed by combination of all those initiatives. This is the result, okay? I don't have to say anything. You conclude based on what you see here. The red bar are the dollar invested in 2012 money. The blue bar are the actual money. This blue curve here is the installed capacity growth. As you can see that the PERPA 1978, this growth, this slope, that's because of that, okay? In 1980, the gas price spiked up. Look at what it did to the installed capacity of geothermal. If you plot the gas prices or the stock index on this curve, it will very much match with our installed capacity. Whenever the gas price went up, installed capacity went up. Whenever it went down, installed capacity flattened out. And once again, wherever it started going up, installed capacity goes. The impact of this $400 million, a lot of people say, so when am I going to get it? Investment in R&D cannot be measured in advancement just tomorrow. Sometimes it takes months, years, and in some cases, decades, and I'll show you that later on, right here. In 1980, there was a gentleman who wanted to do a stimulation in a shale field in the United States, a Barnett Shale. All the oil and gas companies laughed at him and said, you really need to get some help. He didn't listen, continued working on it. See what happened? They stimulated one shale, went to 2 and 4 by year 2003. And look at the growth of the gas. And today, the history tells you. I don't have to say anything. That's the impact of technology. So what we are saying that, yes, geothermal looks flat for everybody. So what? We are developing technologies. We are developing the knowledge base. We are providing incentives. If we can solve now the next technological hurdle of EGS, our future is really bright. Okay? So how are we doing it? In the Department of Energy, our current goal is really to develop and sustain our existing resources and move ahead. In the near term, what we want to do is we want to leverage co-produce. In the United States, there are thousands and thousands of oil and gas wells. According to the USGS, each and every gallon of oil we produce, there are 10 gallons of hot water, warm water produced through those wells. MIT report has once again identified that as a huge potential. We are developing, demonstrating, and showing new technology that can leverage a low temperature geothermal resource and produce electricity. We were able to demonstrate in Alaska that 165 degree Fahrenheit, 75 degrees C, warm water can also produce electricity because of the ambient temperature, okay? The delta T, that's important. We have done that, okay? Those are the type of technology now are being considered in other places, okay? The very new project came online near Hot Spring. It's not that hot like you find in Iceland and everywhere, but we are still using it and producing electricity. What else we want to do near term? In 2008, USGS, United States Geological Survey, identified that there is a 30 gigawatt of undiscovered hydrothermal systems in the western United States. So out of 10 identified, we were able to do 3, that's 1/3. If we can continue and get another 1/3 from 30, that's another 10 gigawatts. That's a huge jump in the United States. And then finally, we want to tap the EGS challenge, and we have done that. Where have we done it? We have 3 successes as of last year. The Desert Peak. We were able to stimulate a well with almost 0 injectivity. It was 0.001 gallon per minute per PSI into a commercial scale 1 to 2 gallons. So many order of magnitude more injectivity. Not just one stimulation, but the multiple zone stimulation. We did that. That's one success. The second success is at the geyser. Once again, we drilled close to 3.5 to 4 kilometer deep, able to stimulate it with just the hydraulic pressure and cold water, and produce at the shallow 3 kilometer reservoir. So this is where it shows how you can stimulate the deeper reservoir and produce from the shallow. Allows you to sustain your existing reservoirs. We have so many other reservoirs like that in the United States where we can still do the same thing and bring up or sustain those reservoirs. And the third example is the Newberry. Newberry volcano, that area, according to USGS, has 400 megawatt potential, 2 to 400 megawatt. It produces big zero. Several wells, so much money poured in over the years to do the exploration. We were able to stimulate the well using a new technology that Ultrarock has developed, and it's a chemical diverters, where they were able to stimulate one zone, injected the diverter, pressure came up again, made sure that it sustained, went down further, stimulated another zone, and then continued stimulated in third zone. This area is in such a place where we could not do the flow test right away. So we are hoping to plan that in the near future. Quickly giving you an idea that this triangle is really a true continuum that takes Desert Peak, which is an infield, to the geyser, which was the near field, to the Newberry, which is almost like a hot, dry rock. So the way we are doing it is going in an infield, getting more resource, going to the near field, expanding the resource, and then going to the hot, dry rock, where adding new resources. So this is our strategy to go after the EGS. On top of all those things, because the EGS has a lot of challenges, we have decided, and we are working very hard to develop what we call EGS Underground Field Observatory. Please do not misuse it as a UFO, but it is Underground Field Observatory. Over here, we will try to resolve or answer so many questions. Question of cost of drilling. Question of how to create a reservoir by using same techniques over and over again, or using different techniques to create better results. Also, how can you sustain the production? And how do you characterize all those things? So we are talking about, on the right-hand side, the tools and the solutions. And in this field, we are planning to drill in one observation well, which will go to the depth of the resource, say 3 kilometers. Then we will drill a horizontal well, and that horizontal well will be stimulated just like shale gas at multiple places. In the United States, most of the fractures are near vertical, so this will allow us to create multiple fractures in the subsurface. And then we will drill a production well, which will be at the little shallower, and produce it from there. And by doing that, we will try to develop zonal isolation tools, high temperatures, monitoring, diverter technologies, and also the new drilling technologies. I forgot to mention another success we had was in one of the drilling technology, spoliation drilling. we were able to show that instead of 8 to 10 feet per hour, they were able to demonstrate almost 3 times the performance in a hard crystalline rock by using a supercritical water. It's a hydrospolation drilling. That company, once again, was funded during our Recovery Act project, and we are continuing that kind of research. Another research through our another innovation branch in the Department of Energy called ARPA-E, we funded called laser drilling. And as a matter of fact, either today or this week, we'll be finalizing a deal with Foro to continue with how we can apply that in geothermal technologies area. And finally, in 2008, we had done what we call a risk mitigation report. In the risk mitigation, there are ways how you can mitigate the geothermal risk. For that, what's needed is the database. Everybody talks about it. We are doing it. We will have the database. It'll be available to everybody, free of charge. It'll be on a public platform. It will use non-proprietary data, software, as well as the hardware. So if you want to be a node on the system, you can join us. You can just download the software, use our protocols, and make it up, okay? And you'll be on an NGTS. Currently, it's available, and you can go and visit it. We have over 2 million wells data on this one. It will be Google type. You go there, click on an area you want or the well, and you can explore more information. And finally, oops, going in the wrong direction. And that's the end of it. So